So question 23 said, it wrote out, said, triangle ABC is congruent to triangle XTY, or whatever letters they use. And then they gave you coordinates for A, B, and C. All right? And then they asked you to find XT, TY, and XY. And we look at that, and then every time that you think of coordinates, okay, or they provide you coordinates, this is what you want to think about. Distance is equal to the square root. Now this is the Pythagorean theorem here, but to maybe be a little bit more explicit with what we're going to do, we're going to take x2 minus x1 and we're going to subtract those and then square that quantity.
Didn't we already do this?
Okay. Oh yeah, we did this once.
Yeah, I did not like it.
And it's going to keep coming back. Okay, so this is going to be something we continually do. So it's good to learn it now because later on it'll be easy to kind of address those problems. But this is the formula that we always want to think about when we're given ordered pairs right now in geometry. Until I give you a different formula, maybe we start talking about slope eventually, so then we'll think about that. But right now, when they ask about anything in this course with ordered pairs, this is one of the things that you want to think about. Okay, and in general, like I said, it doesn't always end up being distance that you're interested in, but they're asking for length, so that tells us distance formula. But the different formulas that you know maybe from coordinate geometry is slope. Okay, y2 minus y1 or x2 minus x1. That's something to commit to memory. You know the midpoint formula, x1 plus x2 over 2, comma y1 plus y2 over 2, and now you know the distance formula. So those are kind of the things that when you see in any question ordered pairs pop up, those are kind of the three things you want to think about. And then, you know, it just kind of narrows your focus on all your geometry, all your algebra, and now you can pick out, okay, of those three, which one are they asking about? Are they asking about slope? Are they asking about midpoints? Are they asking to find length? Okay, so we're going to use that formula. All right. Now, you don't need a picture with this, but I think a picture is helpful in regards to organizing our information. So I've plotted these points in GeoGebra for us, and the way everybody's points were generated, you're going to get a horizontal line and you're going to get a vertical line. Now that's not ideal for every problem. You know, not every single triangle is going to be a right triangle, correct?
Yeah.
All right. But what this allows to happen, because the way your points were created in the algorithm that they're using to develop the ordered pairs, you're always going to get a vertical line and a horizontal line, and those distances are really easy to find. Okay. I want to find. Let's just find the hypotenuse first. Let's go find AC first. Okay. Because that's going to be the harder one to find. AC. Okay. Using the distance formula, we're going to let one of those points be x1, y1, let the other one be x2, y2. And if you remember previous times we've talked about this, it doesn't matter which is which. So I'm just going to let this one be x1, y1, and let this one over here be x2, y2. Okay. Now as I do the distance formula, then distance is equal to the square root of x2 minus x1. So take your x's and subtract them. What's negative 3 minus 2?
Negative 1.
Negative 5. Okay? We're then going to square that. So that there is the x2 minus x1 squared that we saw in the formula right here. We subtracted the x's, and then we're going to square it. Okay? The next thing says subtract the y's, and you're going to square those. Okay? So I'm going to look at my y values, and I get negative 4 minus 3. What's negative 4 minus 3? Negative 7. So now I'm going to square that. So now I'm going to evaluate. So that gives me 25 and what, 49?
Yep.
Okay, what's 25 plus 49? What's 25 plus 50?
75.
75.
71. Never mind.
So it's going to be 74.
Oh, 74.
Okay, so 74 ends up being that length. Now, I think they ask you, maybe you can put it in decimal form or whatever. So you type that in your calculator, get that back. If we type in radical 74 into our calculator, it is going to spit back that decimal, 8.6. Okay, and I think they were okay with you putting 8.6 in.
How'd you land that perfectly?
Huh? What are you talking about?
How'd you get 8.6 perfectly? Like you just clicked the there.
Oh, I just clicked the. I click on the distance thing up here and then click that. And it's actually, if I view out to like 10 decimal places, you see that it's not really 8.6. Okay, so it's getting rounded when I write 8.6. But I think they're asking for the 10th place or 100th place or something like that. So that's how you would find A to C. Now, if your triangle was not a right triangle, you would do the exact same process for now finding this segment here, BC. Does that make sense?
Yeah.
You just let, B maybe be x1, y1, and C be x2, y2, and you go through the exact same process again. But since our triangle is, in fact, a...
Just count.
You could. Doesn't hurt to count. I guess it does work in this situation, but I would be careful with doing that, because what if I end up giving you something that looks... Let's get rid of that. Get rid of that. Somebody in the last class, I was zoomed in like this, and they said count the boxes.
Yeah.
Well, if I count the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there 10 units, a distance of 10 between x being negative 3 and x being 2? No. Okay. So right now what I've got set up there, you can't see the x-axis. I don't have numbers on it, but if I put numbers on the x-axis, show numbers, you're seeing that I'm zoomed in, and every line is 0.5. Does that make sense? For every line. And the same thing happens if I zoom out. Maybe I'm zoomed out real far, and people say, well, count over, and you count over 2.5. But look at the intervals. Each line is worth 2 units, right? So counting is really only a good idea if I've got maybe lines developed for my integers, okay? But that works. But the best thing to do, I guess the default thing to do that will always work, is let that be x1, y1. Let this be x2, y2. Okay? Now if I find the distance of C to B, so distance of CB, I can take the square root. Now subtract your x's. What happens when I subtract my x's? What's negative 3 minus 2? Negative 5. So I'll square that. And now what happens when I subtract my x's? What's negative 4 minus negative 4? 0. Okay? In any horizontal line, that number, that difference of your y's will always be 0. Does that make sense? Okay? So, keeping that in mind, if I go ahead and evaluate this, I get radical 25, right?
Yep.
Or just 5. Well, and that's the idea of that is because that gives me 0 right there all the time on horizontal lines, and I'm always going to be left then with basically the square root of something squared. Well, the square root of something squared, they're always going to cancel out, and it's just going to leave me that radicand, the positive version of that radicand. Okay? And if we think about where that negative 5 came from, it was just the difference in your x's, right? It was negative 3 minus 2. But we want it to be positive because of the distance, so we take the absolute value. That's the quicker way of finding the distance of a horizontal line, is just to subtract the x values. Okay? Because there is no y value difference. That's 0. Okay? If I look at my y values, okay, look at this vertical line here. Which values would you subtract there to get a distance? If I try to find the distance of A to B, if I subtract my x coordinates, what do I get?
Oh, 0.
0, right?
Yeah.
So I don't want to subtract those because that doesn't give me a distance. So what should I subtract then?
The 3 and the negative.
The 3 and the negative 4. What's 3 minus negative 4?
7.
7. So I'm going to take 3 minus negative 4, take that absolute value, gives me 7. Absolute value is 7. Does that kind of make sense to everybody? So when your lines are vertical and they're horizontal, the distance formula is just subtracting the corresponding x values if it's horizontal, subtract the corresponding y values if it's vertical. Okay? That should also then back up what we've already figured out with the hypotenuse here. If this was 7 units here, and this was 5, right? Okay? If this is a right triangle, what theorem is always true about a right triangle?
It's always 90 degrees.
It is always 90 degrees, but what number one theorem did you guys talk about maybe 7th, 8th grade that you deal with right triangles?
Pythagorean theorem.
Pythagorean theorem. A squared plus b squared equals c squared, right?
Yeah.
Well, A is 5, so you're 25. B is 7, so I go 49. That should equal C squared, right?
Yeah.
So if I take square root, I get that, right?
Yeah.
Well, isn't that the exact same thing we found up here when we used this as formula here? So this is formula and this is formula and the Pythagorean theorem are identical. They are the same thing. Okay. Now, that being said, go back to the question that was being asked. We just found A, C, AB, and BC. I think AC was radical 74. AB was the 7. And BC was 5, right? Is that anything that they asked us to find?
No.
No. Okay.
Wasting time.
It might seem like a waste of time, but if I look at the congruency statement up here, AB is the same thing as what?
XT.
XT. Yesterday we talked about corresponding parts of congruent triangles are congruent. So AB and XT, they are the corresponding parts. The triangles they came from were congruent, right?
Yeah.
Okay. So that means that AB's length is the same thing as XT's length. So if I wanted to find XT, come down here, it's the same thing as AB. XT is 7. What about TY? What's TY going to be equal to?
BC.
BC. And BC was 5, so TY is 5. And then XY was the same thing as AC, and that's going to be radical 74. Does that kind of make sense? All right. They will always give you enough information to kind of work through the problem. We just have to be thoughtful of what formulas that we need to kind of recall and use, and then understand that when they give me that congruency, they're actually giving me two triangles congruent, but inside that there are 6 congruent statements that I can make. Angle X congruent to angle X, angle B to angle T, angle C to angle Y. They are congruent. Segment AB is the same as segment XT, BC is the same as TY, and AC is the same as XY. So those 6 things are gained from that initial congruency in the triangle, the 2 triangles. Does that help going over that? Make a little sense? All right. We will continue to go through those types of problems as we go through the course. And we'll